Hello students, welcome back to Akshar ID Foundation classes. I am your chemistry faculty S. Mohan. So grade 9 IIT Foundation chemistry, under this we started in the chapter Isomerism. This is the second chapter of volume 2, right? At the first class we discussed about the introduction of isomerism and types of isomerism, and in that we also discussed chain isomerism, right? Did you remember? Chalo. Once again, 2 minutes, briefly revise, and then we go to the next topic, right? Isomerism. What is meant by isomerism? Compounds having same molecular formula but different properties are called isomers, and the phenomena is called isomerism, right? So now isomerism are of mainly classified into two types, right? So here the first one is open and closed, right? So otherwise we can say structural and stereo. In the structural, again there are divisions are there. It is classified into 5 types like chain isomerism, position isomerism, functional isomerism, metamerism and tarterism, right? So in this we discuss about the chain isomerism. So once we discuss about the chain isomerism, once again I'll give one example, just one example to you about the chain isomerism, right? So the chain isomerism means what? Here, if there is a difference or change in the root word, right? For example, I have given to you like N-butane, right? N-butane. Butane formula is what? C4H10, right? So how can this we can write? So 1, 2, 3, 4 carbons, right? 4 carbons with a single bond, okay? And here we can write CH3, CH2, CH2, CH3, right? So 4 carbons and 10 hydrogens. So this is called N-butane. Why? So here in this is chain root word 1, 2, 3, 4. Okay, 4 carbons are there. 4 carbons is called what? But. And here all single bonds are there. So N. So this is called N-butane also, right? Now the same thing, how can we write? We can also write 1, 2, 3, and one I'll write like this. Okay, now how can I write here? CH3, 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 CH, right? So here the root word, see, here also 1, 2, 3, 4, 4 carbons, and 3 plus 3, 6 plus 3, 9 plus 1, 10. Okay, 10 hydrogens, same. But here the root word is what? Here the root word is 3. It consists of only 3 carbons. So this is what? Propane. What is called a prop, right? 3 carbons is what? Prop, and single bonds are there in propane. But for the second carbon, methyl is there. So 2-methyl. Okay? Propane. 2-methyl propane. So here the longest chain is but, here the longest chain is prop. So where there is a difference in the chain. So this is called chain isomerism. And of course this is also called as isobutane. Okay. So this is also called what? Isobutane. But here we discuss, okay, in the chain we have to show the difference between the chain. So that's what here we take the but and here we take the prop. So this is an example for the chain isomerism. This already we discussed in the last class, right? So now today we are going to discuss about the position isomerism. What is the second one? Position isomerism. Okay. So what is meant by the position isomerism? So here, if there is a chain same, okay, root word remains same, but if there is a change in the attached groups, means branches, okay, branches, position of the branches or positions of the double bond or triple bond or position of the functional groups, then we can call it as a position isomerism. Okay, how the position isomerism? Once you see here, for example, I'll take okay, so I'll take simple one. I'll take first I'll take 2-methyl pentane. Okay, 2-methyl pentane. So see students, now 2-methyl pentane. So how can I write 1, 2, 3, 4, 5 carbons are there. So single bonds, Okay. So here what I do, I'll keep here one more carbon and write here H3. Okay. So I'll write H3. Now see here, this is H3, this is H, this is H2, this is H2, this is H3. Now what is the name of this one? 1, 2, 3, 4, 5. So root word is 5, right? So 5 means what? Pentane, right? So pent is a root word and all single bonds are there, all single bonds. So means what? Ane. So this is pentane. Now to this pentane, there is one methyl. So this is called methyl group CH3. This is attached to which carbon? 1, 2, 3, 4, 5. So for second carbon, methyl is attached. So what can I write? 2-methyl pentane. What can I write? 2-methyl pentane. Okay. So the name of this one is 2-methyl pentane. Is this clear to you? Once you check, is it correct? 2-methyl pentane. Right. So that is 2-methyl pentane. Now see here. The same thing I can write like this also. Here I am writing with a different color so that you can understand. So see, same structure I am writing. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Right. So now here one methyl is there. So this methyl, what I do? I write the methyl here CH3. Right. So CH3, CH2, CH, CH2, CH3. Right. So now what is the name of this one? The name of this one, if you see, here this is the longest chain. What is the longest chain? How many carbons? 1, 2, 3, 4, 5. So 5 means what? Pent. So pent and all single bonds are there. So ane, pentane, right? This is pentane. But to this pentane, there is one methyl group is there here, methyl group. But to which carbon is attached? 1, 2, 3, 4, 5, right? So now I'll write, so this methyl group is attached to the third carbon. So I'll write 3-methyl pentane. This is the name of this one. Okay. Now if you see here, the number of carbons remains same. Total number of carbons 1, 2, 3, 4, 5, and here it is 6. Here also 1, 2, 3, 4, 5, 6. And see hydrogens, you 3 plus 1, 4 plus 2, 6 plus 2, 8 plus 3, 11 plus 3, 14. Correct? So right, this is now here also if you count 3 plus 2, 5 plus 1, 6 plus 2, 8 plus 3, 11 plus 3, 14. Chalo. So here the number of carbon atoms and hydrogen same, here also number of carbon atoms and hydrogen atoms are same. But where is the difference then? Here the position of the methyl group is 2. Here the position of the methyl group is 3. So here there is a change in the position of the methyl group, right? So such type of isomerism is called position isomerism. Clear to you once you check it out? Okay. Now, so here we have taken alkyl group. Okay. Other than, can we take any other one also? Yes, you can take. For example, I'll take 1 butane. So but means what? 4 carbons. 1, 2, 3, 4. Okay. If I give the number 1, 2, 3, 4. Okay. So what I'm doing here, I'm giving the double bond here. Okay. Here single bond. And here how many hydrogens are required? 2 hydrogens. Here already 3 is there. So 1. Here 2. Here 3. Now what is the name of this one? 1, 2, 3, 4. 4 means what? Bute. Okay. But is there all single bonds? No. Here there is a double bond. So double bond means what? Ene. Right? So this is ene. But this double bond is present to which carbon? It is present between 1 and 2. So what the number we should give? 1. So the name of this one is but1ene. What we can say the name of this one? But1ene. Okay. This is 1-butene, or you can write simply 1-butene also. Okay. 1-butene. Right. But this is the IUPAC name. Okay. But1ene. Now the same structure I'll write like this. Here I'll change the color and I'll write So CH3 CH double bond CH3. Okay. Now here you see how many carbons are there? 4 carbons. 1, 2, 3, 4 means what? But. Right. Now whether all single bonds? No, this is what double bond is. So double bond means what? In. But this double bond is present between which carbon? 1, 2, 3, 4. So we have to write for second carbon. So 2 in. What we write? 2 in. Now see the difference. What's the name of this one? But 1 in, but 2 in. But if you see the number of carbon atoms, number of hydrogen atoms. 1, 2, 3, 4, 4 carbon atoms. 1, 2, 3, 4, 4 carbon atoms. Hydrogens 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8. So 8. Alright, now here we check. 3 plus 1, 4, 4 plus 1, 5, 5 plus 3, 8. So here also 8. So C4H8. Both are having the same molecular formula. Okay. And where is the difference? Difference is in the position of the double bond. Here the position of the double bond is 1. Means what is it is? Double bond is between 1 and 2 carbon. Here the position of the double bond is between 2 and 3. So this is a 2. So if there is a change in the position of the alkyl group, means attached group, or it may be chlorine, fluorine, anything, even means a functional group also. Okay. For example, you say I'll take same butane, I'll take. Okay, butane I'll take. So now here you can see C 2 3 4, pent I'll take. Okay, pent. But here what I'll do here is I'm taking the chlorine here. What I'm taking? Chlorine. Okay. If you can take alcohol also. Alcohol functional group is what? OH, right? So then we take OH also. Okay. So I will take OH here. Right. So then it becomes what? CH3, CH, CH2, CH2, CH3. Okay. Now what is the name of this one? 1, 2, 3, 4, 5. 5 carbons are there. 5 means what? Pent. Okay, pent. And all single bonds are there. Ane. Okay, so ane, right? Pent, ane. And here one alcohol, which is what? Alcoholic functional group. Okay, alcohol is called what? All. To which carbon? Second carbon. Okay, so now what we write the name of this one? Pentane, pentane to all. Pentane to all, or 2-pentanol also we can write. But IUPAC name is this one, pentane to all, or 2-pentanol. Okay, now this we can write like this also here. CH3, CH2, CH, CH2, CH3, and here I'll put the OH here. Okay, so 1, 2, 3, 4, 5, that is what? Pent. Okay, all single bonds ane. But which carbon this alcohol attached to? 1, 2, 3, 4, 5. Okay, for third carbon. So what can I write? 3, alcohol is OL. So pentane 3 all. So this is pentane 2 all. But if we count the number of hydrogens, carbons 1, 2, 3, 4, 5. So 5 carbons, 1, 2, 3, 4, 5, right. Now hydrogens is here, 3 plus 1, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 3, 11, plus 1, 12, 12 hydrogens, right. So 12. Now let's see here, 3 plus 2, 5 plus 1, 6 plus 2, 8 plus 3, 11 plus 1, 12. Okay, right. And one oxygen. Okay, so this is the formula. So both are having the same formula, but same formula, same functional group, but where there is a difference, there is a change in the position of the functional group. Such type of isomerism is called position isomerism. So once again, see students here, position isomerism what? If there is a change in the position of the alkyl group or functional group or double bond and triple bond, okay, then it is called as a position isomers, and the phenomena is called position isomerism, right? Once you check. Right. So that's about the position isomerism. Once again, see position isomerism we have given with the alkyl group, we have given with the double bond and with the functional group, right. So after the position isomerism, then we go to the functional isomerism. Okay, the third one is functional isomerism. What is meant by the functional isomerism? Same definition, compounds having same molecular formula. Compounds having same molecular formula, but it differs in functional group. But it differs in functional group. Okay, so then such compounds are called functional isomers, and the phenomena is called functional isomerism. Okay, so see in your material what the definition is given. If the molecules have the same molecular formula but different in the type of the functional group, then it is known as a functional group isomerism. Okay, now for example, they have taken one formula C2H6O. Okay, what they have taken? C2H6O. See students now, C2H6O. Okay, how can we write this one? Now observe carefully here. I can write like this: CH3, CH2, OH. Now here I am writing C here, CH3O, CH3. Right? Now see here, how many carbons? 2 carbons. 2 carbons. Okay, satisfied. 3 plus 2, 5 plus 1, 6. 6. 3 plus 3, 6. And here one oxygen, here one oxygen. Okay, right. Now you say whether this both belongs to the same functional group. No. First you try to give the name. So here how many carbons are there? 2 carbons. 2 carbons is called what? Eth. Okay. And between 2 carbons, which bond is there? Single bond. Ane. And what is this functional group? OH, alcohol. Means what? All. So the name of this one is what? Ethanol. Ethanol means what here? What is the functional group here? Alcohol functional group. What is here? Alcohol functional group. Right. Now here you see how many carbons are there? 2 carbons. But between the 2 carbons there is one oxygen. So this is a form of ROR. So what it is? Which functional group I said this is? Ether functional group. What it is? Ether functional group. So here one methyl is there. Here one methyl is there. In the middle oxygen is there. Right? So the name of this one, and this belongs to ether functional group. Ether. So what we can give the name? 2 names. One is called dimethyl ether. 2 methyls are there. 2 is called dimethyl. This belongs to which functional group? Ether functional group. Ether. Right? Now here you see, according to IUPAC name, so here methane. So this is called meth. Okay, then what is there? Oxygen. So oxy. And here methane. So the name of this one is methoxymethane. Here what it is? Ethanol. Ethanol, methoxymethane. Both are having same molecular formula, that is 2 carbons, 6 hydrogens, 1 oxygen. So molecular formula is the same, but that these two belongs to 2 different functional groups. So compounds having same molecular formula but differs in functional group, are called functional isomerism. Is this clear? So this is all alcohol, this is ether. Okay, methoxymethane or dimethyl ether. Right? So see once you check this one. Okay, we can give one more example like with aldehydes and ketones. Okay, so the aldehydes and ketone. What we can give aldehydes and ketones? Propanol we take. What is the propanol? You know what is the propanol? Okay, CH3, CH2, CHO. Okay, so what is the name of this one? How many carbons? 1, 2, 3 carbons. So 3 means what? Prop. Okay, and single bonds are there. Ane. Okay, and last CHO is there. So CHO is a functional group of what? Aldehyde. For aldehyde, what is the suffix? Al. So the name of this one is propanol. Okay, and this is which group? This is aldehyde functional group. Which group it is? Aldehyde functional group. Right? Now the same thing, how can we write? Can we write like this also? See now, CH3, C double bond O, CH3. Okay, so CH3, C double bond O, CH3. So when there is a double bond to one carbon, this functional group is called what? Ketone. Yes, This is ketone. Now what we can give, how many carbons are there? 1, 2, 3. So 3 is what? Prop. Between the carbons, which bond is there? Single bond, ane. But for ketone, what is the suffix? One, O-N-E. So O-N-E. So the name of this one is what? Propanone. What is the name of this one is? Okay, propanal. Okay, for aldehyde, suffix is what? Al. For ketone, suffix is what? On. And this is different functional group, this is different functional groups. Now see total how many carbons are there? 1, 2, 3. So C3. 1, 2, 3. C3, right. Now here 3 plus 2, 5 plus 1. 6 hydrogens are there. Okay. Here how many are there? 3 plus 3. 6 hydrogens are there. Now here 1 oxygen is there. Here also 1 oxygen is there. So this both the compounds having the same molecular formula, that is C3H6O. But okay, this belongs to the aldehyde group, this belongs to the ketones functional group. So hence this both are having the different functional groups. Compounds having same molecular formula, but they belongs to different functional group, they are called functional isomers, and the phenomena is called functional isomerism. Right? So this is a third one, functional isomerism. Once go through this one. Okay, now the fourth one. Fourth one is metamerism. What is the fourth one? Metamerism. So metamerism. What is a metamerism? Here also same, the compounds having same molecular formula, but if they joined with the different alkyl groups, So see here, page number 81, you have the definition. It arises when different alkyl groups, are joined with the same divalent functional group present in the molecule. Okay. So that is an example. Let us see now. You can understand here. For example, what I do is ethoxyethane. I will take. What I will take? Ethoxyethane. So ethoxyethane, what can I write? So I can write like this: C2H5O, C2H5. Okay. So here 2 carbons are there. So this is called eth. And here oxygen is there, oxy, and C2 carbons is there, ethane. So the name of this one is what? Ethoxyethane. Right? So if I expand this one, then what I'll get here? See, this will expand. That becomes CH3, okay, CH2O, CH2, CH3. Okay. So here see middle oxygen, and here 2 carbons, 5 hydrogens. See 2 carbons, 3 plus 2, 5 hydrogens. Here also 2 carbons, 5 hydrogens. 2 carbons, 5 hydrogens. Okay. So here for this carbon, 2 carbons this side, 2 carbons that side of on either side of the oxygen. So this is called what? Ethoxyethane. Ethoxyethane. Okay. Otherwise diethyl ether also we can call it as. Why? Because this is ethyl, 2 ethyl, that's called diethyl, and this functional group is called ether, so diethyl ether. Did you understand? Sure. Now see now, here you see, if I write the structure like this, okay, so CH3O, C3H7. What I write here? Okay, CH3O, C3H7. Otherwise, I will write in expanded form also. So CH3O. Now this way can I write CH2, CH2, CH3. Right? So the same thing in expanded form I have written. Right? So see now, what is the name of this one? So here only 1 carbon is there to other one left side of the oxygen. So this is called methyl, right? So this is called methyl. Okay. So meth. And in the middle what is there? Oxygen. So what I write? Oxy. And here how many carbons are there? 3. So what can I write? Propane. What can I write? Propane. So what's the name of this one? methoxypropane. What is the name of this one? Methoxypropane. So see here, this is oxygen. Here left side only one CH3, that's called meth, and 1, 2, 3, 3 carbons called prop. So propane. So what's the name of this one? Methoxypropane. So this is ethoxyethane. This is methoxypropane, right? Now let us see in both the compounds how many carbons are there total. So here see 2 carbons, here 2 carbons. So total number of carbon atoms are 4. So I am writing C4. How many hydrogens are there? 5 plus 5, 10. So I am writing 10 hydrogens. How many oxygens is there? Only one oxygen. So this is the formula. Okay, this is. So C4H10O. Now here you see here 1 carbon plus here 3 carbons. 1 plus 3, 4. Yes. So C4. Now 3 plus 7. Here 3 hydrogens. Here 7 hydrogens. 3 plus 7, 10. Right. Now here 1 oxygen is there. 1 oxygen. So this is called metamerism. What is called? Metamerism. So metamerism means what? Here if there is change, see it arises when different alkyl groups are joined. Different alkyl groups are joined with the same functional group. Okay. So here you see functional group. This is also ether. This also ether. Both belongs to the ether only. Yes or no? Because see in the middle oxygen is there, on both the sides alkyls are there. So these both belongs to the ether functional group only. Then where is the difference? The difference in the alkyl group which is attached to this one. So left side here ethyl is there, right side ethyl is there for this one. But here left side methyl is there, right side propyl is there. Okay. So this difference is called metamerism. Clear metamerism? Okay. If two compounds having same molecular formula. Okay. But here difference is what? Here the different alkyl groups attached. Different alkyl groups attached to the same functional group. Then that is called okay, metamerism. Clear? Once you check the metamerism. Right? So this is about the metamerism. Now last and final one, let us see tartomerism. Okay. Tartomerism is the last and final one. So let us check the tartomerism. Tartomerism. Tartomerism definition, if you see students in the page number 82. Tartomerism is a phenomena in which a single compound exists in two readily interconvertible structures that differ in the relative position of at least one hydrogen. So here what we do is, see now, observe carefully here. I will take one compound so that you can understand here. I am taking CH3, C double bond O, CH3, right. So 1, 2, 3 carbons, that is prop, right, okay, prop, and between carbon there is a single bond N, and this is what? Ketone, okay, C double bond O, ketone, so that is one, okay. So the name of this one is what? Propanone, correct? Okay, this name is what? This one is what? Propanone. Okay. Now what happens, students, here? Under certain conditions, okay, then what happens? It interconvertible, okay, it changes. How it changes? See here now. Here you see, I write like this: CH2, C, okay, here I will put double bond, and CH3 single bond OH. Okay. Now see here, this is, you can see here. Observe carefully here. These two structures, if you observe here, how many hydrogens are there? 3 hydrogens are there, right? But here how many hydrogens are there? 2 hydrogens are there. And between carbon and oxygen, which bond is there here? Double bond. But between here carbon and oxygen, what happens here? Single bond. Why? So here one of the hydrogen, okay, one of the hydrogen from here it is shifted there. Okay, one of the hydrogen it is shifted there. So CH3 became CH2, one hydrogen is going there. So CH2, one hydrogen is going there. So this becomes OH. So when it is loses one hydrogen, now single bond becomes double bond. So when it is losing one hydrogen, then its single bond becomes double bond. And when hydrogen is added here, then double bond becomes single bond. So here when hydrogen is added here, so double bond becomes single bond. Okay, so this is okay, and this is what 1, 2, 3 carbons, 1, 2, 3. So 3 carbons is what? Prop. Okay, prop. And a double bond is there. So not single bond, double bond is there. So in, and which group? A function group is what? Alcohol. Which is what? Alcohol. Okay, to all. Right? So this type of compound is called enol. What it is called? Enol. Enol, why? En means double bond, all means alcohol. Enol, enol. Okay, double bond and alcohol. Clear? But here what happened here? This is a propanone became propene to all. Enol. So enol. Clear? Enol. Right? So here what's happening here? The same compound. See, if you see the formulas, once you see the structure, let's see the formulas. How many carbons are there total? 1, 2, 3, right? So here I am writing overall formula. So 3 carbons, 1, 2, 3. So first we write this one. See, 1, 2, 3 carbons. How many hydrogens? 3 plus 3, 6 hydrogens. 6 hydrogens. Here one oxygen. Okay. So this is this compound. Right. Now let us find here. How many carbons? 1, 2, 3. So 3 carbons. And how many hydrogens? 2 hydrogens here plus 1, 3 plus 3, 6. So 6 hydrogens. And here one oxygen here. So here compound remains same. Okay. Both the compounds having the same molecular formula. Okay. But what's happening here? This is interconvertible to another. Means this compound is converting into another compound. Okay. And this is called, this both are in dynamic equilibrium. Very important point here, you have to remember that. This Tarterism arises when they are in dynamic equilibrium. Equilibrium means what? Equal. Means for example, you see students here, I'll write, okay, the symbol like this. Okay, interconvertible. Means what? Propanone is converting into the propene to all. Propene to all is will be converted into propanol. So this can be converted into this one, this can be converted into this one. Okay. For example, if I take initially, if I take only this one, there is no product. So this is called reactant, for example, and this is called product. Okay. I am taking only reactant. Okay. Under certain conditions, this reactant is converting into the product. For example, you see this is 100%. Let imagine 100%. Okay. Now this slowly what happens? This reactant is converting into a product. So then what happens? For example, this 100% is converting into, for example, 10%. You think. Then what happens? It becomes 90%. This becomes a 10%. Now then the reaction is going on. This 90% becomes to 80%. This becomes to 20%. And still reaction is going on. 70, 30, 60, 40, 50, 50. Okay. Now what happens? Now this comes to 50, this comes to 50. So then, okay, both become equal. So such condition is called dynamic equilibrium. What is called? Dynamic equilibrium. So when both the compounds are in dynamic equilibrium, okay, this both will be in equal. Okay, a dynamic equilibrium will be there. Okay, and one more important thing is that here, for example, if the reaction is going on, there is a reactant, there is a product. Some of the product you removed, you think. Some of the, okay, dynamic equilibrium means what? Now no interconversion is taking place. So this both became equal. So this is converting into this one, this is converting into this one, both are in equal, okay, amount out there. But for example, you think if I remove something from here, then what happens? Again the forward reaction will be taking place. Okay. Acha, that we'll discuss in the later classes. Did you understand now? Tarterism. So tarterism definition once you see in your material. Tarterism is a phenomena, page number 82, is a phenomena in which a single compound, so this is a single compound, exists in two readily, okay, exist in two readily interconvertible structures, means this can be converted into this one and this can be converted into this one, okay, interconvertible structures that differs in the relative position of at least one hydrogen. See here 3 hydrogens, here 2 hydrogens, here no hydrogens, here 1 hydrogen. So here there is a change in the position of isomerism, so that different structures are known as tautomers. These two are called tautomers, and this phenomena is called tautomerism. Did you understand the tautomerism? So once if you have a textbook, once you open the page number 82, okay, and read the definition and try to understand this one for 1 minute. Is this clear, tautomerism? So that's about the tautomerism, right? So here one more important, just okay, sometimes tautomerism is also called as a Desmotropism. Okay, tautomerism is also called as what? Okay, Desmotropism. Okay, Desmotropism. Why it is called Desmotropism? Because in the Greek language, desmo means what? Bond. Okay, desmo means what? Bond. And tropos means what? Turn. So bond turns means what? Changing the bond. So here you can see this is a single bond, here it is a double bond, right? But if you come here, this becomes a double bond and this becomes a single bond. Okay, so there's a change in the bond. Okay, bonds will be changed. So that's what is also called as Desmo. Okay, Desmotropism, right? So that's all, students. So with this topic synopsis 1 is finished. So once again I'll discuss briefly, then we go to the practice sheet. Okay, so once again briefly let us see here. This chapter is what? Isomerism. Isomerism is what? Compounds, 2 or more compounds having same molecular formula but they possess different physical and chemical properties, okay, are called isomers, and that phenomena is called isomerism, right? Isomerism is mainly classified into 2 types. One are called structural isomerism, second one are called stereoisomerism, right? So in the structural isomerism, mainly it is divided into 5 types. One is called chain isomerism, second one is called position isomerism, third one is called functional isomerism, fourth one is called metamerism, and fifth one is called tautomerism. So here this is an example for the chain isomerism, because why it is called chain here? See here in the root word 4, this is a chain, longest chain 4, so bute. But here the same compound, but the longest root word is 3, propane. So if there is a change in the chain, okay, root word, then that's called as a chain isomerism, right? Then come to the position. If there is a change in the position, so see here, methyl is attached to the second carbon of a pent, so it's called 2-methyl pentane. And here methyl is attached to the third carbon of pent, so this is called 3-methyl pentane. Pentane remains same, root word is same, but where is the difference? Here position of the methyl, second carbon, here it is the third carbon. Okay, this is called position isomerism. And some other examples also you can see here. Bute 1 in, bute 2 in. So chain remains same, but position of the double bond here is 1, here position of the double bond is 2, right? And here alcohol also, this is also position isomerism, pentane 2 all, here pentane, but alcohol is attached to the second carbon here alcohol attached to the third carbon, only position of the attached group will be changes. This is called position isomerism. Then what I said, functional group. So functional isomerism, if there is a change in the functional group, total functional group, one functional group and other functional group. So here you can see now, here this is ethanol, so functional group is alcohol. Here it is dimethyl ether or methoxymethane, this is ether functional group. So functional group are different. This is alcoholic functional group, this is ether functional group, but formula remains same. Okay, so if there is a change in the functional group. So here you have to, very important thing you have to remember is that, so alcohols, these are what alcohol, okay, shows the functional isomerism with ether. Remember, this is very important. Alcohols shows the functional isomerism with the ether. Similarly, aldehydes. So see, these are what aldehydes here. Aldehyde shows functional isomerism with the ketone. Okay, so propanal aldehyde, propanone. Okay, both are having same formula, but here it is a aldehyde functional group, this is a ketone functional group. Okay, so here aldehyde can be show the functional group with the ketone. Then come to the metamerism. Metamerism is what? The difference in the alkyl groups. So here you see, this is a ether, this side 2 carbons, this side also 2 carbons, so this is called ethoxyethane. But the same compound, you can, if you write like this, so you see for this oxygen left side, only 1 carbon is there, so meth, but here 3, okay, prop. So total number of compounds remains same, that is C4H10O. So they both belongs to the same functional group only, functional group same, but alkyl groups what we are attached, that is different. Okay, so that's called metamerism. And last and final one is what? Tarterism. Tarterism is what I said, okay, the two compounds which are interconvertible, okay. So interconvertible, so here this is a interconvertible compounds. If it takes place, then that is called as a tarterism. Example is propanone and propene to all. Okay, so that's it, right? So now let's come to the, open the page number, some questions let us solve here. Practice sheet 1, right? And come, let's explore, right? The first one, organic compounds having same molecular formula but they differ in their physical and chemical properties. Lesson name only. Compounds having same molecular formula but different properties are called isomers, and the property is called isomerism. So answer is what? 1, that is isomers. What is that? Isomers, correct? So take the first option. First option is the right answer. Okay. Now second you see, chain isomerism is a type of chain isomerism, structural, geometric, stereo, optical. Structural, the structural 5 are there, no? What are they? Chain isomerism, position isomerism, function isomerism, metamerism, tarterism. This all comes under which isomerism? Chain isomerism. So the option is once again 1. Next, but 1 in, but 2 in. But 1 in, but 2 in. But 1 in, but 2 in. This of which type of functional group? Here I explained you see here. Your position of double bond is changing. Only 1, 2. So this is what? Position. Okay, this is an example for position isomerism. So answer is 1 again. Okay, third question is also 1. Fourth question, alkenes are isomeric with, okay, alkenes are isomeric with, alkynes no, cycloalkanes, right? How it is cycloalkanes? Now see. For example, I will take butane, okay? Achha, I'll take cyclobutane. But means what? 4 carbons. But cyclo means what? Closed structure, right? So 1, 2, 3, 4. 1 bond, 2 bond, 3 bonds, 3, 4 bonds. So this is the structure, okay? Now these are closed. Now you see here, this carbon has 2 bonds with this one bond with this one bond. So it valence is 2, so CH2. And this carbon also has 1 bond here, so CH2. This carbon also has 1 bond and here 1 bond, so this is also CH2. And this carbon also has 1 bond here, CH2. Okay, so total how many carbons? 1, 2, 3, 4. So 4 carbons, C4. Okay, C4. How many hydrogens? 2, 2, 2, 2. 2 4s are 8. Right? So this is. Now if I ask you what is a butene formula? Butene, ene means what? A double bond. 1, 2, 3, 4. Right? So ene means what? There should be one double bond. So I'll keep here double bond here. Single bond, single bond. So double bond is there. So more it requires 2 hydrogens. Here 2 bonds, here 1 bond means only 1 hydrogen. Here 1 bond, here 1 bond, here 1 bond means it requires 2 hydrogens. Here only 1 bond is there, 3 hydrogens, right? So here now you see here 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8. So 8 hydrogens, 1, 2, 3, 4 carbons, C4H8. So this is what? Alkene. Okay, here all single bonds are there. What it is called? Cyclobutane. So An means what? Alkane. So cycloalkanes formula is similar to the alkenes, right? So the option is 2. The fourth question option is what? 2. Now fifth question. Alkynes are isomeric with the same here. Okay, alkynes are isomeric with which one? They are cycloalkenes. Okay, alkenes are isomeric with the cycloalkanes. Alkynes are isomeric with the cycloalkenes. Okay, so the option is third option. Right. Now fourth option. Acids show the functional isomerism with esters. Why esters? Acids functional group is what? COOH, carboxylic acid. COOH, right? So what is the structure of carboxylic acid? C. For example, let us take ethanoic acid. Okay, CH3COOH. Okay, propanoic acid. CH3COO. Sorry. CH3CH2COOH. This is propanoic acid. Okay, and with what they are saying? Showing as well as ester. Ester is what? COOR. Okay, so how can I write now? See here, CH3. Okay, C double bond O and CH3. Okay, so now you see how many carbons? 1, 2, 3. 1, 2, 3. Okay, 3 carbons. Okay, hydrogens 3 plus 2. 5 plus 1, 6. 3 plus 3, 6. Okay. Here how many hydrogens? 2 oxygens. Here how many oxygens? 2 oxygens. O2. So this is the acid. COH is called acid, carboxylic acid. COR is what? Ester. These are called what? Ester. This already discussed. So acid shows the functional group with the esters. Next, nitroalkanes. Nitroalkanes and alkyl nitrates. See. Nitroalkanes, alkyl nitrates. They do shows the difference in the functional isomerism. So first one is the right answer. Aldehydes are isomers with just how I told you. Okay, aldehydes are see here. Aldehydes are functional group with the ketone. Aldehydes with the ketone. So the option is 2. Aldehydes are isomers with the 2. Eighth one is 2. Ninth one. Isomerism which arises due to the presence of different alkyl groups on either side. Different alkyl groups on either side. Say different alkyl group. Here 2 carbons, here 2 carbons. But here 1 carbon, 3 carbons. So different in the alkyl groups on both sides. That's called metamerism. So option is third option. Ninth one is 3. Right? And last one, see the type of isomerism in which substance exists in 2 dynamic equilibrium. Just now I told you dynamic equilibrium. This is, okay, this is called dynamic equilibrium, right? So this is what Tarterism. So option is 1. So like this. So student, this is a very important chapter and you need to practice here. First you read this one. Okay, after reading, then try to answer the remaining questions. Okay, so with this we completed the first synopsis of the isomerism. This synopsis is very easy compared to the next 2 coming synopsis. Okay, why? Because in the next synopsis we are going to discuss about the stereoisomerism, little complicated. Okay, so to understand that one, this is very important. So first topic, this one, synopsis 1, isomerism. Read very perfectly and try to practice some structures, so then it becomes very easy to you to understand the second one. Okay, so students, with this we stop the class. Take care. Bye.